Hello, everyone. Great to be here today. My name is Ryadh. I'm in charge of the integrations at ClickHouse from a product perspective. ClickHouse is a company that builds a fast open source OLAP database. And my background coming from different technologies, search, logging, observability, and now at ClickHouse, I've always been interested about the intersections of these spaces. And this conference topic about open source observability is, I think, a great fit for our discussion today. And we'll try to summarize here what's happening in that space around concepts we coined as SQL-based observability. So let's dive in. First, I wanted to start this presentation with a map that I really like. It's a map of the Mediterranean region from the 14th century. And you'd ask yourself why this map is on a technical talk. First of all, it's gorgeous. That's one of the reasons. But the second one is like if you take a close look and you look at the coastal part of the Mediterranean, you'll notice like many cities, so many that the author of the map had to like write the names vertically aligned to the coast map. And the reason is that that's where people lived back then. There was an area of like cultural exchange and trade. And for that to happen, people had to agree on using the same language. And quickly it became obvious to everyone, and they started using this language, and we refer to it as the lingua franca, which was the trading language. And then by extension, this term lingua franca was like used for many kind of domain specific languages. And if you pause and ask yourself, what's the lingua franca of data and data manipulation? I guess we can safely say that it's SQL. Many languages exist out there to manipulate data. They provide different capabilities and functionalities, but the kind of oldest and most powerful language that's still around these days is SQL. It's exactly 50 years old this year. 1974 was when the Watergate scandal happened, was when The Godfather Edition 2 was released, and that's when SQL was created. We still use it to this day because of its simplicity. It's available in many types of data stores, and every developer, every engineer, every data engineer has been exposed to SQL at some point in his career. However, it evolved with the data applications, and some data applications require different types of SQL, roughly into two categories, OLTP and OLAP. We refer to OLTP as online transaction processing. It's basically when your database is the source of truth or the backend of your application. So it needs strong properties from a consistency perspective. Asset, it needs to handle the throughput of transactions and provide coherent reusers. And it's usually row oriented in the way data is stored on disk. Another family of databases is what we refer to as the OLAP databases, obviously, more focused on getting results on aggregated data, large data sets. Usually the queries try to group by some field and understand like phenomena and extract insights from the raw data. And we care here about the query latency, just the ability to manage these volumes of data, the throughput. And to achieve this, very often the data source needs to represent data by columns, grouping together the homogeneous data sets into these columns to benefit from some properties. And many data stores exist. You can write your SQL query, group by any of your feeds, get your result. This is actually from ClickHouse on the screen, but can be any database. And that's basically the SQL story. In parallel, observability as a field is now part of our daily life in any IT landscape, and wanted to also dig a little bit on the roots of this and where it's coming from. And interestingly, stumbled upon this picture, which is from a ship, like a sea captain writing down the events that happened on the ship. And we refer to this as the log book of the ship. And that's where logging actually as a domain came from. It's because in the ships they used to throw logs at the sea to have like a static reference point to measure their distance from the shore. And that's why we still say logging, even though we deal with computers and there's no, I guess, pieces of wood involved. So it's a pretty old idea, logging things, logging events to be able to understand a phenomenon or monitor a situation. And it evolved with the evolution of IT, obviously. Centralized logging was, I think, a big milestone in systems like syslog, for example. And it snowballed, obviously, since the data architectures and layout were more and more sophisticated. Many companies who experienced the high growth rate started to invest in that area and build their own like observability systems. And they did it with the technology available to them. Like, for example, Twitter at its peak used Cassandra and many other distributed systems to like store, represent uh, telemetry data, expose it as dashboards, give the users alerting systems on top of it. So it was really like a kind of patchwork of technologies that was used initially to propel these systems. And then it quickly became also a commercial domain with like vendors packaging the offerings from collection, storage to visualization and alerting. Some vendors like decided to like cover all the areas and still cover all the areas. And we still see these things happening, unfolding. But an interesting evolution recently happened, obviously, with the help of open source, which for a while was impacting many different domains. But in the observability space, I think a very important shift happened with the Open Telemetry project. The Open Telemetry project is a set of SDKs, software packages, specification, and even like standard that represent the way to collect, process, and ship data to observability stores and front ends. And this standardization is what's really powerful about this project, is that for the first time, we have now a very approachable and standard approach to tracking these events and collecting them. And we can delegate the other functions to other systems like time series databases, trace databases, or column stores. So if you roll back a little bit, we spoke about SQL and databases and OLTP and OLAP. We spoke about observability and its evolution and its standardization through open source. If you just put these two tracks, one on top of each other, and notice the main milestones, you'll notice that we're reaching a stage where the two paths can collide and can basically be used in conjunction. I think thanks to the open source standardization, thanks to the tooling available like Grafana, thanks to standardized ways of deploying software like Kubernetes, now we have a way to like ship these events, and the advanced and the availability of fast and powerful real-time all-up data stores like ClickHouse or others make it possible for us to treat observability as any other data set and propel the use case. So that's the main idea of what we refer to as SQL-based observability here. It's really like treating it as a data problem. ClickHouse can be one of the backends. You can use your preferred backend. If you have something else, this talk is actually not really opinionated from that sense. It's just that I happen to work for ClickHouse and I know it better than the other data stores. But really, if you stop thinking about observability as a kind of special use case and really treat it as another data problem, then this opens up the space of what's possible to do with this data. First of all, it frees up many innovations around the use case. For example, you're not tied to what the observability vendor has decided to provide to you. You have standard data, you can put it on your data store, you can put it next to your business data, to operational data, to other reference data sets, and then you can cross-analyze, correlate, and really benefit from all the power of fast querying engine. And you can do that and consume this data through various ways. What makes an all-app store the right fit for this type of use cases is few things, in my opinion. It's all about getting answers and getting them fast, and the ability to ingest high volumes of data, transform it, enrich it on the fly if needed, and then accept important throughput of queries is key here, because you want to know about your issues as soon as they happen, or this reduce the mean time to resolution to its minimum. And this is powered by the fact that these platforms can now deal with large volumes of data in a very efficient way. Data compression is also a great characteristic of many of the column-oriented databases, because they store homogeneous data sets that benefit from a lot of compression capacity, and ClickHouse is pretty impressive in that sense. We'll see some numbers later on. Separation of storage and compute, I think, is an interesting thread here, because it really allows to think about bottomless architectures in that sense. You're not tied to the capacity of your disks in the server. You can use something like object storage as a backend, trade off a little bit of latency in favor of greater operability and unlimited storage capacity. Interoperability, or like the openness of the model, means that you can pick your stack. We have a recommended stack at ClickHouse. You might want something else. You might want to build your custom solution on top of it. You might want to run a client that performs run ML models on top of your data sets. This is all possible because you're treating your observability data as a first-class data citizen in your landscape, and you can just use anything available to you. And extensibility, it means that your data can be in any format, any location. From a database perspective, it's just like a data set, and unlocking this power is really key to understand the use case. So to illustrate this a little bit better, if you take like a regular observability pipeline that consists in like collection, storage, and visualization, you can pick the right components for each step of the stack. For example, we do recommend OpenTelemetry when we also maintain and contribute to the OpenTelemetry exporter for ClickHouse that can run in your nodes, that can be then aggregated through an OpenTelemetry gateway node. If needed, you can send that straight to your data store. You can use queuing from that point, and it's really a data pipeline, a pretty standard data pipeline. Once it lands into your data store, you can run server-side transformations in ClickHouse with features like materialized views. You can pre-aggregate the data for your users for like very fast response times, and you can expose this in many ways. If your users are comfortable writing SQL queries, you can just, well, give them a SQL client to your database, or use something like the ClickHouse Cloud SQL Console. Or if you want to provide a UI dedicated to alerting, open source solutions exist. The main one being Grafana, for which we also maintain the Grafana plugin for ClickHouse, which is all OpenTelemetry native in its conception. Other solutions, maybe you want like a custom data visualization solution. Maybe you want to use something like Superset. Maybe you want to write your own app and you have other use cases you want to fulfill. You want to see your observability data next to the business data to measure business impact of downtimes, things like that. In that area, it's pretty open-ended, and that I think is probably the main advantage of that model is that you're not tied to a predefined scenario. You can pick and choose and extend the way you want to really support your use cases. One project I wanted to highlight in this, for which ClickHouse is not supported yet, but it's an interesting one, is called Perses, which is a new data visualization platform, CNCF project, and that can be also interesting for people to have a look at. So enough theory, let's talk about some real world examples. People have been running this kind of SQL-based observability model for observability workloads for a while now. If we take the example of a company like Uber, they documented their logging use cases. They use different log shippers. They have queuing in Kafka. They built a custom connectors for ClickHouse to interact with Kibana. And through this setup, they won in terms of like scale and speed and ingestion, as well as keeping the costs of the platform in check. However, they had to make some trade-offs. So obviously, administrating the stack and building a custom UI is not something that anyone can do. But at the end, it really looks like the reference architecture I displayed. Fairly straightforward. Data is coming from various systems through Kafka and then ingested into ClickHouse, where it's exposed either through UI or API access. eBay is another example that adopted an all app store, ClickHouse in that case, for tracing this time. And this one introduced OpenTelemetry, which is the project I was talking about. Standardizing on OpenTelemetry allows basically to use standard tools in the stack. However, they had to build a custom tracing UI since this use case was a bit ahead of its time. And I guess the Grafana plugin that now supports tracing for OpenTelemetry data was not ready back in then. So the big one wins on costs and data compression, the fact that it's open source license. However, there is some management, obviously, overhead for all the collection layer around OpenTelemetry. And as you can see, overall, it really looks like the use case I described earlier. Traces are collected in different managed apps running in a Kubernetes environment. The telemetry collector sends that to the trace store in that case, which is ClickHouse, and there's a console that takes care of abstracting that for the users. Finally, a use case I'm really excited to talk about today is our own use case at ClickHouse Cloud around using ClickHouse as our main observability store. Usual suspects here, OpenTelemetry, ClickHouse, and Grafana. We do keep every log line for a very long period of time, virtually unlimited period of time. And we can retain that because the costs are in check using something like ClickHouse with its compression capabilities. We just, for the fun, we simulated if we had to use something like a serverless platform for that. And yeah, it would have cost in north of 26 million per month if we had to do it. Obviously, it's a custom stack. We documented it pretty well in the blog post linked below. And in this custom stack, there is 1.5 full-time engineers that are working in maintaining this. It looks like this. We have Kubernetes nodes that are running OpenTelemetry agents that are shipping data to OpenTelemetry gateways. And then there is our ClickHouse, basically deployment that is the destination of these data sets for which we access with Grafana. So it's fairly simple. We refer to this project as Loghouse. And very happy with the performance and the scale at which we are operating it. In fact, we store north of 43 petabytes of uncompressed data in there, which thanks to ClickHouse great compression capabilities is compressed down to 2.4 on object storage here, so a compression ratio of 18. And you can see that we keep ingesting around 10 to 11 million rows per day. So it's not just about big numbers, not just about shiny numbers. It's really about using a very standard way of solving data problems. And we've been doing it for many, many years already with SQL. And the ergonomics of the use case are also interesting to see. So let's take a simple query here displayed in two different variants. One is Splunk version on the left, which basically looks for events filtered on the warning level and then grouped by with some aggregations that are related. Very powerful query language. However, there's a learning curve and the pipe orientation of it is not easy to manage for everyone. On the right, this exact same query, which runs a group by aggregation on the same fields, this time using the Elastic DSL. And in terms of expressivity, if we take the same use case and do it in good old SQL, you'll see that it's pretty intuitive and easy to read. So it's the simplest group by query. It's very easy. The learning curve for SQL is not that hard, to be honest. So you can unlock many, many capabilities by just enabling your analysts to use SQL Store as an observability store. Then, even if this is too much, we also have the ability to generate SQL queries. And this is an example here in ClickHouse Crowd, where you just ask your question in plain English. And thanks to generative AI, there's an LLM that will help convert your query and provide the SQL equivalent. So here we get the 10 longest trips. You can run it straight away and you have your answer. So in terms of usability and approachability, I think SQL benefit from like these years of inertia in the market and documentation available. And the GenAI approach is a great example. So that was it for me. Thanks for listening. If you want to hear more about the use case, there's a blog post around the same topic called The State of SQL-Based Observability. We are available in our public Slack or on any social media platform if you want to hear more about this. I'd be really curious if you have use cases that leverage stacks like the one we displayed here. So feel free to reach out to me if you need anything. Thanks for having me today.